So this, you can see, you need quotient rule. You cannot separate this around the addition in the denominator. So let's go do it. So y prime will be low cosine of 3x plus sine of 3x times the derivative of the high. Notice that this is just pi. So the derivative of pi is 0 minus high and then d low. Okay, so I'm taking the derivative of cosine. I get negative sine. You carry that 3x along. Then you multiply by the derivative of 3x, which is 3, plus take the derivative of sine. You get cosine. Carry the 3x along, and then multiply by the derivative, and you get 3. And that's all over cosine of 3x plus sine of 3x all squared. Okay, so let's see what we've got going on here. So I see that this is all multiplied times 0, so that's 0. Okay, so let's simplify before I go plugging it in. I see I have a negative pi times a negative 3 sine of 3x. Okay, so that's going to turn into a 3 pi sine of 3x. And then if I multiply this negative pi times this term, that's going to give me a negative 3 pi cosine of 3x all over cosine of 3x plus sine of 3x all squared. Okay, now I'm ready to plug in the value they've given me, right? They're telling me plug in pi over 2. Okay, so let me bring it down here. So I want you to get in the habit of using the notation. Plugging in pi over 2 in for x, so I get 3 pi. So that's sine of 3 pi over 2 minus 3 pi cosine of 3 pi over 2 all over cosine of 3 pi over 2 plus sine of 3 pi over 2 all squared. Okay, so let's look at this. So this here is negative 1. Cosine of 3 pi, that's supposed to be a 3 pi over 2, right? Cosine of 3 pi over 2, that's 0. So that's all gone. And this down here, cosine of 3 pi over 2 is 0. And then sine of 3 pi over 2 is a negative 1. So I get a negative 3 pi, and this is negative 1 squared. So that's a positive. All right, whew, that's the slope. So I also need the point. So I need to plug pi over 2 into here, right? So y of pi over 2 will give me pi. Then I'll have cosine of 3 pi over 2 plus sine of 3 pi over 2. So that gives me pi, and this is 0, and this is negative 1, so I get negative pi. So my xy point is pi over 2, negative pi. Putting it together, equation of the tangent line, y plus pi equals negative 3 pi x minus pi over 2. All right, a couple more. So let's see if I can fit this next one in this video. So I want to find out all the x values where the slope of the tangent line, I didn't say it very well, where the slope of the tangent line is parallel to this. Slope of the tangent line to this is parallel to this. So let's start by rewriting this as negative 3x plus 1. So the slope I want to be parallel with, I want it to get slope of negative 3. Okay, so you know how to find slope. Slope of a tangent line is the derivative. So the derivative will be negative cosecant squared, carry the 3x along, and then multiply it by 3. Okay, so I want this, negative 3 cosecant squared of 3x, to equal negative 3. Well, look at that. The negative 3's cancel. So I get cosecant squared of 3x is equal to 1. So you know when we take the square root, we get a plus or minus, right? So I've got two equations going on. So I'm going to have the equation cosecant squared of, or not squared, not cosecant squared, cosecant of 3x equaling 1. And I'm also going to have, cosecant of 3x equaling negative 1. Okay, so you know this is, excuse me, 1 over sine. So this, by cross multiplying, gives us sine of 3x equals 1. This is 1 over sine of 3x equals negative 1. So this gives me sine of 3x equals negative 1. Okay, so let's think about what that looks like. So, so when I'm trying to find when the sine is 1 or negative 1, thinking about that unit circle, sine is 1 here, sine is negative 1 here. So they're pi apart from each other. So I can say 3x, the angle, right, is equal to pi over 2 plus k pi. So then I divide through by 3, I get pi over 6, k pi over 3.